Okay, we can probably get started. Hopefully you're in the right place. Here to learn about best practices for testing endpoint protection products. My name is Peter Havens. I'm Director of Product Management here at Palo Alto Networks, focused on endpoint protection, on traps and XDR. I've been with the company about a year and directly responsible for some of the endpoint testing that goes on for our products as well. Hopefully I haven't, early on in my career, I was trained by University of California in computer science. Hopefully I didn't introduce too many vulnerabilities in the first decade of my career, but moved into product management about 10 years ago. So into the mobile management space with MobileIron, and then Centrify for privilege management, and now here at Palo for endpoint security. So thanks for joining me. We're going to take a dive into looking at how you can evaluate and test endpoint security products and make a decision on which is best for you. So first, how many of you represent an IT or security organization that's using endpoint security products in your organization today? Hopefully I'm going to see everybody's hand, unless you're a Palo person. Okay, maybe a show of hands. Who doesn't have an endpoint security solution in your organization? Okay, good. Let's talk to you specifically. We'll get you hooked up with one by the end of the session. How many of you are evaluating maybe switching or bringing on new products? Okay, so hence the reason you're here. Hopefully we'll learn a few tactics on how you can do that evaluation in this session. Okay, so first let's talk about the landscape, the threat landscape. For this session, because everybody talks about endpoints and everybody has a different definition of them, and just because our product, when we talk about endpoints, we're talking about more than just workstations and laptops. We're talking about the whole gamut of computing devices, including mobile devices, servers, and virtual environments as well. So whether your laptops or workstations be Mac OS or Linux or Windows, everybody's heard of that one, whether your mobile devices are Android or iOS, and your server operating systems, Linux, Windows, you name it. No Mac OS servers out there anymore, I hope. But and virtual environments including VDI, AWS, Azure, etc. So we're talking about that entire landscape in this when we talk about endpoints. So a little bit more on the cybersecurity landscape. This is kind of ever evolving, and I don't have some of the older ones, but it'd be interesting to take a look and see how the malware landscape has changed over the years. And here's just a couple examples. Changes from 2017 to 2018, and it's kind of hard to see those down at the bottom. The green is Adobe Flash, and then you've got Android in red, which actually decreased a bit from 2017 to 2018. And then in yellow, browser, of course, browser-based exploits, or browser-based malware, which actually also declined a bit. The fastest growing category in this year, and I haven't seen the 2019 yet, I think it comes out shortly, was actually Word documents. Not Word documents, but Office documents. A little bit of increase in PDF. PDF is still relatively small. But this is just kind of a summary of the different types and frequency we see malware and or exploits. We'll talk about both of those in the different application environments. There's Java in there as well, which also shrank a bit. And what did I miss? I think that's all of them. So let's talk a little bit about the applications that are being used. I think part of the reason that we're seeing more malware on Office and not so much browser-based exploits is because it's easier, right? So if you're doing malware that's going to attack a browser, the browsers are getting much more advanced in terms of their self-protection capabilities, and they're constantly being updated quite frequently, whereas Office is frequently out of date. And you don't have to stand up a website necessarily to attack via an Office document. It's just a lot easier. There's a lot less you have to do. You don't have to stand up a website. You don't have to route somebody to that website necessarily. You can just embed some malicious code in an embedded object, either in a macro or some other mechanism. And I think, by and large, we see a lot of organizations keep their browsers up to date quite frequently, but still are running old versions of the Office suite. So it's a prime target for a lot of attackers. This is another source that kind of breaks it down by delivery mechanism. I think most of you probably know this by now, but maybe not the exact number, but 76%, according to this survey from SANS in 2019, 76% of malware is delivered through email-based threats. And the next category is web-based drive-by downloads, followed by application vulnerabilities, or on users' endpoints, and then web server or web application vulnerabilities, similar to the other one, but specifically for web apps. Removable storage, USB, is just behind that. and then user endpoint misconfiguration and or configuration not up to date, which relates to exploits above. But still, email is the most common delivery mechanism. So all just different methods to eventually get something to execute on the user's endpoint. Email attachments can include many things, obviously Office files. I'm sure many of you are partaking in sharing those Office files via email. PDFs with vulnerabilities, images, scripts, encrypted files, and the list goes on and on and on. There's so much you can deliver through that mechanism. So just a little bit more about the cybersecurity landscape. We're not talking, I touched on this, we're not talking just about Windows. How many of you are using Mac in your environment? How many of you are using Linux on the desktop in your environment? Growing. Wow, that's actually more than I've ever seen in response, like percentage-wise. That's good. Linux servers, Windows servers, obviously a lot. Okay, great. So when we're talking about this, we're talking about all of these operating systems. Our Trap solution also supports Android as well. Anybody doing actual mobile threat detection or mobile security other than like enterprise mobility management, like VMware or Mobile Iron? Okay, I didn't think I'd see any hands go up on that. So that's still kind of an evolving space. All right, so let me just talk a little bit more about the threat landscapes. Difference between exploits and malware. So exploits usually depend on software or operating system vulnerabilities. These are things that the attacker has to find on your environment, whereas malware is a file they can drop on just about any on any endpoint. Malware exploits are taking advantage of specific versions of the operating system that have not patched a certain vulnerability, or of applications that have not patched a vulnerability. They take some skill and some techniques to actually invoke, maybe return-oriented programming, or address space layout randomization, DLL loading, or heap spray. Lots of different techniques, but they actually require a bit more expertise on the attacker side to actually create. So they're a little more less opportunistic than malware, which can easily be just transported as a file or as a download. Malware is often, viruses or worms or other sorts of traditional malware that we're quite familiar with, and usually requires the user to interact with it or to perform some operation to actually download it and execute it on the endpoint. All right, so with malware also, malware behaves differently on different endpoints. It's very much dependent on the application, not dependent on the applications, but it will behave differently. It's an executable usually that's running and targeted for the operating system, but not targeted so much at specific exploits or OS versions or application versions on the endpoint. So let's just take a look at an example here. This is the Microsoft Office Equation Editor ZeroDay. Anybody heard of this one from 2018? Okay, pretty well known. The reason I bring this one up is because it kind of highlights the need for, when you're testing for endpoint solutions, not just to look and see whether a particular CVE is blocked, but malware is getting quite sophisticated. This one in particular uses several exploits in different areas of the application stack to execute on the endpoint. So it begins by a user running an RTF file on the endpoint, and that RTF file actually uses an embedded object to stage a DLL. And it stages that DLL in the temp directory and masquerades it as a zip file. And then after that, it actually executes two CVEs. In case you've got one patched, it's going to try the other one. So it's doing CVE, I think it's 1182, which is the Microsoft Office memory corruption vulnerability. And then it's also trying another CVE, which is, I think, 2018-0802, which is to do with a vulnerability in the font system within Office. And these vulnerabilities existed and have been since patched in Office 2007, Office 2010, Office 2013, Office 2016. So they've been around forever, for quite a long time. And it took a very long time for Microsoft to patch them. And when they did, they went back and patched it for all versions of Office. But this wasn't until 2017. The vulnerability had been in use and been around for quite some time before that. So what it actually does is it executes and loads some shell code, which then actually puts a file, a w.dll, into the plugin directory for Word. And in the plugin directory, that makes sure that every time you start up Word or Office, it's restarted. So persistence is there. And the actual payload that does something malicious is actually the temp.exe. And so every time you're loading up Word, it's again trying to execute this temp.exe. So I highlight this one just because it's important to make sure that when you're testing the effectiveness of a security product, that you're not just using a sample that's provided by the vendor itself that's selling you the software, but you're actually trying against real-world samples, right? And because these samples are getting much more sophisticated, it's not just one technique, one malware, or one CVE that you need to protect against. They're now spraying across multiple techniques and using different mechanisms to persist and to infect the endpoint. Okay, so as we're thinking about how you should test, I want you to keep these things in mind. I mentioned don't use tools that were developed by the security vendor. So if somebody from Palo Alto Networks walks into you, does a POC, and says, we got a test for you that's going to prove that we're the most effective solution. First of all, call me, send me a note, because that's probably not the right way we should be doing it. The reason I say that is because it's really easy for a vendor to create something that only their software blocks, but it doesn't represent necessarily real malicious code or real malware or real CVEs. It's meant to demonstrate techniques, but it doesn't actually show you whether or not something is malicious. And when you run that sample against another vendor's product, they may not fire on it because what they're doing in that sample is not actually malicious. It's kind of a demonstration of a malicious technique. All right, so use actual malware. Test exploitations and malwares differently based on what you're seeing. Malware is quite a bit different than exploitation. Exploits, you actually have to probe the system and make sure that those vulnerabilities exist in your environment. And make sure that when you're performing the test that you're actually doing it on your environment, not necessarily on the live environment. You don't want to execute real malware on somebody's endpoint that's on the network, but make sure that the system and the software stack, the OS patches and the application patches that are on that endpoint actually reflect what's happening in your environment, because then you'll know for sure whether or not that malware would affect you guys. So use real scenarios, use email attachments. If you're executing real samples, don't do it in the network and the live network, because a lot of these things move laterally, and you don't want to do that necessarily. So make sure you're doing it in a lab environment using systems that are representative of your real systems and the software stacks that you're using. Don't do it just once, right? Things evolve. The malware's evolving. Things that were patched at one point tend to reintroduce themselves as vulnerabilities in a different way, but repeat those tests. And there are actually breach and attack. I think there's a segment now called breach and attack simulation vendors that actually do this, right? They actually can install tools on your network that will continuously test against different techniques and make sure that you're continually protected. So breach and attack simulation vendors. They're not in my presentation, but I think I can think of a few. Safe Breach is one. Attack IQ, they generally work in such a way that they're installing a simulation tool. So it's not actual malware. So it goes against the principle there, test real malware. But it's doing so, it's leveraging the techniques and capabilities, but doing so on a handful, maybe 1 to 5% of the systems in your environment, and doing so on a random cycle. So it's constantly kind of evaluating how effective your security stack is. Really cool way of making sure that you're continuously protected. And I'll also talk about verifying with third-party services. So if you don't have the manpower to do your own testing or to continually do that, make sure that the solutions you've chosen are vetted by security test houses. We'll talk about some of those as well later on in the presentation. And just keep an eye on that once you've made a decision. Make sure they're staying up in the game, right? So an important part of that process. Now, if you're going to evaluate things yourself, how many of you are actually doing live evaluations in a lab or in your environment? Anybody? It's a little intimidating at times, right? So especially if you're trying to do, malware is pretty easy. We'll talk about malware in a minute. You can actually download samples from a number of different places, and it's relatively low lift in terms of effort to actually do that. Exploits can be more challenging, right? As we talked about, first you need to identify that an exploit would actually have a chance to get a foothold in your environment. You have to probe what types of exploits would actually have a chance on your endpoints. And that takes a lot of research, but there are tools out there to help you do that. First one is Windows Exploit Suggester and or Linux Exploit Suggester. It's a tool that you can download. I think you can run it in Linux or Kali Linux if you happen to be using Kali. We'll talk about that. And you can run that package and point it at an endpoint and actually have it profile to see what exploits might be best to use in terms of testing for that endpoint. Very, very helpful to help you kind of quickly get to an understanding of what you should be testing based on the software stack, the patches you have in your environment. Getsploit is another one. Getsploit is just a wonderful way to actually go and search by type, by the type of attack mechanism, by the type of operating system, lots of different ways to actually go and search. So you can, I think we're giving the decks out for these presentations. The links are here, or if you just want to take a note of these names, we use these all the time for our own uses internally, and they're really, really good. So take advantage of them. You don't have to go and discover this on your own. In fact, doing so is arduous, challenging, because more often than not, you'll get something, but it's already patched, and you'll think that the software product is actually protecting against it, but it may not be exploitable in your environment. Is there a question in the back? I see a hand. Nope, just waving. Hi. All right. Some other tools. You've probably heard of a lot of these. Metasploit, Kali Linux. Kali Linux is just a fantastic, simple, lightweight Linux distribution for taking on a lot of these attacks, basically using it as a platform to easily install the tools you need to actually undergo some of the exploit techniques or malware techniques. Very easy to leverage Metasploit. On top of that, there are other tools as well, like Cobalt Strike and/or Empire, which were used in MITRE Round 1, if everybody's familiar with MITRE. Anybody ever heard of MITRE? Okay, we're going to talk about that in a little bit as well. Some other tools. Caldera was actually a tool. It's a simulation tool that was created by MITRE. So we'll talk about that a little bit as well. But all of these things can actually be used to help you simulate or take on these different types of exploits and techniques. Just a couple of screenshots of what they look like. They sound intimidating, but actually they're quite simple. Kali is a very simple distribution of Linux. Very easy to get software installed on. It comes pre-installed with a bunch of toolkits that can help you attack or simulate an attack or actually do some of the exploit attacks. Let's see. On the malware side, there are a ton of great places to download malware. I mentioned it's a little simpler than exploits. You don't need to necessarily set up an exploit server or a web server in order to do this. So one of the obvious ones, everybody's heard of VirusTotal. We'll show you a little bit about that if you haven't used it. It's a great resource for actually searching for and finding and easily downloading malware. But make sure that you're actually using real-world scenarios when you're doing malware testing as well. You're just deploying those through email as attachments or maybe through removable devices, USB devices. And if you need good sources for where to source malware, here's a list. One of my favorites there at the top we'll talk about in just a minute. I think everybody knows about VirusTotal, but there are quite a few others out there as well. The reason I like malware traffic analysis.net, it's a site where they're doing constant blogs. Like I think they do either daily or almost every day, maybe 3 to 4 times a week. There's a new blog on a new vulnerability, a new malware, a new CVE. And you can actually download the PCAP. Everybody familiar with what a PCAP is? It's network trace of what actually happens. So it kind of focuses on the interactions that the endpoint has with other endpoints and the attack as you see it from a network stack. But it gives you the full download of that PCAP so you can actually replay it and learn what to look for. More than just the PCAPs and walking you through that, there are training exercises. So you can see here on the left, this is an example of a traffic analysis exercise. So here, they'll give you a screenshot of all of the PCAPs and the text associated with the logs and everything that's happened and kind of walk you through the process of understanding what that exploit did so that you can learn how to evaluate whether something was successful or when and where it was stopped. So great site. Keep it on. There's a Twitter feed associated with it as well. Can't remember what it's called, but if you go to malwareanalysis.net and go to the About section, you'll see the Twitter handle there, and you can follow him. I think his name is, let's say it's Brian, if I'm not mistaken. But a great, great resource. This is one that I use as I got into the security space. Really helps me to understand at a deeper level how these attacks are seen on the wire. Okay, and the exercises also involve both the PCAP but also the endpoint side of it and how you would research it on the endpoint side. So check it out. Highly recommend it. VirusTotal, great place for downloading and actually getting samples or checking whether or not something is considered malicious by a host of different vendors. Be careful on the verdict side of things, right? So VirusTotal, I don't know exactly how they're doing it, but they have a bunch of software stacks installed, and they will tell you whether or not any of the dozens of security vendors think that a particular hash or file is malicious. But most of the time, the versions of the software stack they have installed are old, or maybe not fully deployed, or maybe not configured to the max. So some of the verdicts in there are wrong, and many of the vendors strategically don't say whether or not they consider something malware, because other vendors are using that to actually look up and make determinations as well. But it's a great place to actually go and look for files and download files. You can download Office files, Flash files. You can do a quick search by hash. Here you can kind of see there you can actually search by file type and kind of figure out exactly what it is you're looking for, and then find all the details about that file. So you can see there in the screenshot just about everything you'd want to know about that. You can actually download it. I think it does require a license to use to actually get some of the more advanced queries, but a good resource as well. Okay, so we talked a little bit about malware, a little bit about exploits, where to find them, different tools to use them. But sometimes it's good to have a third party help you in this process, a third-party test house that's specifically focused on this. Maybe it's because you don't have enough security staff to actually go and learn this, or it's an ongoing task that you just want to make sure the software you have in place stays up to speed with the latest attack techniques. So there's a couple reasons you might go with a third-party test house. There's a lot of different ones out there. Some of the ones that we commonly see, actually, let me get into how you would select it. So a lot of things to think about when you're selecting a third-party test house to leverage. What's their completeness of the evaluation? Are they just looking at malware? Are they looking at signature-based, things that are easily identified by signature-based malware detections? Or are they looking at what we've talked about with exploits? Are they looking at fileless malware? How's the manageability and user experience, or the total cost of ownership? What's the rate of false positives in the environment? Are they testing for false positives? How do they score things? Do they only score based on prevention? Because in this world, I don't know if any of you have seen the different presentations on XDR, you can't prevent everything, right? As more and more of the things that are being leveraged in the environment are not actually malware, they're exploits that live on the system that are signed by Microsoft or signed by you name it. They're not necessarily preventable. You can't just stop Word and say, okay, we're blocking that, we're quarantining Word, right? So do they give additional credit for detecting and raising awareness and raising alerts for things that are happening in your environment that are more behavioral attacks rather than malware? It's important, right? It's more getting into the EDR space. Do they look at whether or not a patient zero endpoint was affected or not, or whether the solution can protect against that? And also just the total cost of ownership for the end user and for the administrators dealing with false positives in that environment. All right, so let me just put a few of the vendors up there. Some of you have, everybody heard of AV Test and AV Comparatives, been around forever. They do a lot of both consumer grade and business grade malware testing. They do them annually in cycles, so they do somewhere between 8 to 12 per year. They usually do them in 2-month cycles, and then they'll produce a 2-month score. What's nice about it is you get a very simple and easy to understand kind of a scoring system, 0 to 6 usually, that tells you how effective the solution was, and also oftentimes a performance score that lets you know what the performance impact was with the solution as well. There are other test houses that are a bit more advanced, like NSS Labs. NSS Labs is looking at more than just traditional signature-based malware. They're looking at fileless attacks, offline attacks, exploits, evasion techniques, and other things. Many different techniques. And their tests tend to happen less frequently. They're trying to move to a continuous test cycle as well. And part of the reason for that, I think, is that a lot of vendors sometimes may get caught in a situation where they didn't have a protection on December 18th, whenever the test ran, right? Because they were, for one reason or another, they didn't protect that particular technique, and then they're penalized for an entire year until the test reruns. Not something I'm very fond of, but that's the way NSS does things today. They're looking at moving towards a continuous test cycle, which I'm excited about because that will help I think reward vendors that are reactive to what's happening in the environment, right? So look for that from them. We work with them as well. This next year in 2020, we're going to be working with quite a few vendors. MRG is another traditional test house like AV Test and AV Comparatives. NSS Labs, we'll be working with all of these different solutions. And then there's another one, which does things quite a bit differently. MITRE, I mentioned earlier. people are familiar with the MinorTech Framework. The MinorTech Framework has been in development for quite a few years, I think around 7 or 8 years, and it's essentially this attack, I don't know, framework or Bible, if you will. It's a database of information about all the different attack techniques. We're going to dive into that one a little bit more because I think it deserves some attention. And then analysts are taking all of these test results from all the different sources and essentially using that to help make their determination on which endpoint protection solutions or EDR solutions are most well suited for protecting against current threats. All right, and you can also, actually I mentioned MRG. MRG is a test house that we use independently, so when we want to do our own self-evaluation that we don't publish, we use them today, MRG Effitas, for doing kind of outside consulting and having a look at our security effectiveness as well. So we do a lot internally, but we also sponsor tests through MRG. So let's take a look at MITRE. They do things very differently. So I mentioned the MITRE attack framework is kind of the Bible, if you will, of all of the different tactics and techniques that an endpoint can be attacked through. And so if you've seen it, it looks something like this. There's a couple hundred different techniques across the kill chain. So at the top, you've got the different tactics like evasion, initial access, privilege escalation, execution, exfiltration, all the different types of techniques. And then through the bottom, you've got a bunch of different actual tactics that are used in those different, or techniques that are used in those different tactics. Sometimes you'll see it like this, where it's actually broken out on a per adversary basis. In this case, you're seeing highlights of APT28 and APT29, Cozy Bear, and the other bear, or both. So a lot of adversaries will use the same techniques. This is a complete list of all of the known, in this case, attacks for Windows. And so it's quite common that adversaries will use these techniques. Different adversaries will use the same techniques. Another way of visualizing it in the pinwheel style, you've probably seen it. So MITRE's been all about kind of building that framework and leveraging the community to maintain that framework of attack techniques. In the last year and a half, MITRE started going a different route. As the attack framework has kind of stabilized and not changed as much, they've started doing evaluations, right? We're all constantly updating as a community the MITRE attack framework. But MITRE's now taken another step forward and started doing evaluations. They're doing them very differently than most vendors. They don't generate a simple score, like a 0 to 6 for security effectiveness. They're not testing prevention at all. They're just testing with prevention completely turned off. And the reason they want to do that is they want to see what an endpoint solution can do regardless of when it was installed. So what could it do if there was a slow-moving attack and the endpoint protection solution was installed midway through that? What can it do if it happened to miss any of those steps? So across the entire kill chain of a more advanced attack, what could that endpoint solution actually bring to bear as evidence against that advanced technique? So prevention in this case for all vendors is completely turned off. And they started this end of last year and went into this year. The first evaluation was completed, I want to say at the beginning of or end of 2018. And then a couple other vendors were able to get in. We GA'd our product XDR. And about 2 weeks after, in February, March of this year, we jumped into the last spot for MITRE. We thought it was the last spot for round 1. And did an evaluation with them. So generally, what they do in these evaluations is they take on a particular adversary and they emulate it. They use the tools that they use the techniques that all of the forensics teams have identified as a part of that attack, and they basically replicate it. So in the first round, they used APT3, which was the Chinese Ministry of State sponsored attacks, and they basically replayed those using their own techniques as close as they could to what happened in some of those techniques. So what you end up getting is a detection score. So in the case of round 1, they did 136 actual techniques. And what happens, the end result of that is each and every vendor gets a score per technique. What were you able to show? Were you able to show any information? Were you able to show basic information? Like, let's say it was just probing the network. It was doing an ipconfig/all. Not something we generally want to alert about. But do you have any telemetry on that? Have you captured that information? And can you use that and relate it to information that happens later in the attack? Right? So telemetry is the lowest level of detection. If you don't have any telemetry, you get a score of none for a detection for that technique. If you can go beyond telemetry and enrich that information with additional information about a step that happened prior. They call that enrichment. And beyond enrichment, you can get credit for identifying something as an actual indicator of compromise or raising a general alert or a specific alert. And a general alert is one that just kind of calls out generally what that tactic was doing. A specific one is actually one that ties it directly to a known attack technique that's in the MinorTech Framework. There's some modifiers to those detections as well in round 1. They're changing for round 2. The modifiers were delayed and or tainted. Delayed just meant that if you were actually able to detect or present something about a technique, you did so in a non-real-time manner. So the product didn't immediately show that or show it within a few seconds or minutes later. Generally, that means that the tactic or technique that was used was identified by an MSSP or MDR service and sent an email maybe a few days later or a week later that said, hey, we saw this in your environment, you should be aware of it. Okay, so that's what the delayed modifier was. The tainted modifier sounds like a negative thing. I don't know, in English, tainted is a bad thing. If your food is tainted, it usually means you're going to be sick afterwards. In this case, tainted actually is a good thing, strangely enough. Everybody's confused by it. Tainted means that you're able to take a technique that you identified and taint it with information about a previous step in the technique. The right word I think they wanted to use was correlate. So in round 2, they're changing the detection modifier to correlate. There's a few things they're changing in round 2. So that's just the basic mechanism for scoring in MITRE. So in the end, if you go to Google and you type MITRE evaluations, it's going to take you direct. The first hit is going to take you right into a bunch of tiles for all the vendors that did an evaluation for APT3, and you're going to run into a page that looks like this. All of the highlighted sections represent the techniques that were used in APT3. Okay? So if you actually click on any of those, and this is ours, this is a direct screen grab of the website. You don't need a login to get in there. All of this is public information. You can just jump in and see. So in this case, I think I just clicked on one of the tactics and techniques, and it'll tell you everything that the vendor was able to show for that technique. So for 1B1 there, you can see the steps that they took, the notes that they took in terms of what we were able to detect. And if you click over on the right side there, you'll actually get a screenshot of what the product looks like, or what the MDR service sent as an email, or whatever that solution was able to provide as a detection mechanism for that solution. So just a fantastic database of information about all the different security vendors out there and how their products actually look when they're presented with these advanced techniques. I love the approach that MITRE takes. There's also some things that I think they could improve. They don't test for false positives, which means that you might have your products kind of amped up and alerting on everything. We saw some vendors that just alerted on absolutely everything that happened in the environment. So if you ran ipconfig on an endpoint, boom, alert. You can imagine what your SOC would be like when they're looking at alerts on all kinds of things like that without discrimination as to who was running it or anything. So false positives is something they don't do in the test. Prevention is turned off. We know that a lot of the attacks that we saw would have been prevented had we had prevention turned on. But the other thing that I think is interesting, MITRE doesn't produce any scores. So you get to the website, you have no idea who did well and who did poorly. You just have to pour through this data. So find out what's interesting to your organization and pour through it for each vendor and find the one that's best. It's challenging. But they make it a little easier. At the top, you'll see that little JSON button. So if you're having a little trouble pouring through, you can just grab the JSON, and it's so much easier just to look at this and quickly identify who was awesome. Yeah? You can all see it. You see the detection right there in the middle somewhere. There's one. And no. So this is hard as well, but the nice thing is it's data-driven and allows the community to start contributing tools that will help pull this apart, which is exactly what happened. Kudos to Josh Salonis at Forrester, who created just a simple Python-based, everybody loves Python in cyber, Python-based scoring system that basically pulls down all of the JSON for all the vendors, digs through it, and starts to analyze those detections, pull them out, and associate a score with them. Okay, so his scoring system was pretty simple. Basically, if you had any detection at all, you had telemetry for a technique, you got 1 point. If you had more specific alerts or indicators of compromise, you might have gotten 3 points. And if you got like a general or a specific alert associated with that, you would have gotten 5 points. And so he built this system, and then the Python script just go through and kind of tally all that up and give you kind of an understanding of how the vendors did. And so we entered this test 2 weeks after GA. We were pretty excited about seeing how the product would do. And this is the results. I apologize, some of the names there across the bottom are a little small, but you can see how we did. On the left, you're actually seeing what the first detection I talked about, the none. Okay, so if there was a technique and we had nothing to show for it, we got a score of none. So in our case, we had 15 nones across the 136 techniques. So remember, an attack is comprised of many different steps, right? There's privilege escalation, there's lateral movement, evasion, persistence, initial access, execution, exfiltration, you name it, right? So we might have missed a step here or there, but across any of the techniques that were part of the first one, we had alerts for every single technique. We might have missed or every single attack kill chain, okay? Next closest vendor in the test missed almost double. They had 29 misses. So this told us that the investment we made an acquisition in SecDo about, I don't know, a year and a half, 2 years ago. And we took the time to actually pull traps apart, the endpoint, and re-architect the agent, leverage the best of breed of technology we've got from the SecDo acquisition and integrate that into one endpoint agent. And this was the first kind of test that tested that from an EDR perspective. And we did fantastic from a coverage perspective. Not just that, but we also did amazingly well when it came to the types of detections we got. There's a good write-up by Josh, if you can get it, where he writes up about how each of the different vendors did. And again, I think some of the vendors look really good on paper because their alerts are through the roof, right? They get an alert for every tactic that happened, which isn't necessarily what you want. As an attack starts to build itself out, it's doing legitimate things, right? But it's using those things in a way and a behavior that we can start to identify as malicious somewhere down the line. We just want to make sure we identify it as malicious early enough and can alert it and bring it to your attention so that you can put a stop to it, or so that our prevention mechanisms can put a stop to it. But if we alert on everything, on every one of the 136 techniques, well, you're going to have a really tough job filtering out the noise from the actual things to be concerned about. The other highlight of the result is that, in our case, some of the leading vendors in the market these days, we did equally well in terms of one of the categories that the Python spits out is a category called enrichments and delayed. And I'm not sure why Josh decided to do that, but basically his Python couples those two things. And if you actually dig a little deeper, he has a Python script in there on the GitHub called query attack, where you can actually start to provide it parameters to search for. And if you actually pass it was it a delayed detection, you'll find out that Palo Alto Networks, all of our detections were not delayed, not a single one. Some of the other vendors, one of the standalone vendors that's actually public in the market, I won't mention their name, had an equal number of those types of detection. It turns out that of the 60 they had and the 60 we had 0 delayed. 55 of their 60 were delayed. So those were coming from their MSSP, which isn't a bad thing necessarily, but it's nice to know that our XDR product can actually give you all of that transparency, all of that visibility of what's happening just with the product itself to your analysts, right? And then if you want to attach an MSSP or MDR service through one of our partners, you can do that as well to get that next level of coverage. All right, so just to summarize the process, so there are lots of tools out there available online, so use them. Don't try to take this on yourself. Learn from the community, leverage the tools out there for simulating attacks, maybe leverage a breach or attack simulation vendor like SafeBreach or AttackIQ, or leverage Metasploit or PowerSploit or Empire or Cobalt to actually take on those attacks. Make sure that if you're doing these things, you're doing them in your environment, right? With your endpoints and your application stack and your patches in mind, not just on somebody else's. Do not, I can't stress this enough, do not let somebody come in as a security vendor like ourselves or another company and say, we've got a sample for you, we've got something that clearly shows us as more advanced because we only protect against it. Well, that was a handcrafted solution that has a handcrafted code on the back end to actually fire an alert, most likely, right? It's really great. It's really great for demo. But make sure you're actually testing real malware when you're doing this. Perform them in your real environment. Make sure if you're using real samples, you're doing it in a lab. And then make sure you're evaluating real scenarios like email attachments, drive-by, web attacks. And make sure that you're not just doing this once. If you've used this type of technique for actually evaluating vendors and making a choice, make sure that you repeat those steps on an ongoing basis. Because once you make a decision, it's up to us, the vendors, to make sure we stay up to speed on all of the different attacks. We don't revert any protections we have. And you need to make sure that we're doing the best job in that. excuse me, try not to cough into the mic here. And then leverage third-party test houses for a couple things. If you're looking for a quick comparison, if you don't have the manpower internally or know how to actually do this yourself, you can leverage them for the initial evaluation. But if you do the evaluations yourself, you can still use those services to actually do ongoing analysis of how your choices are keeping up in the market. Okay? Realize that a lot of those solutions are actually for-profit organizations, and vendors are paying a lot of money for them. So sometimes they might be influenced by the amount of cash that's coming from some of the vendors. One of the things I love about MITRE is it is a nonprofit organization. They do charge for the evaluation, but not for profit. They're only charging enough to cover the actual execution of the test. So they're kind of like the white hat of the test vendors in the world. Really well respected. Okay? That's it. That's all I had for you. Hopefully there's some good resources for you here. Any questions? In the back. Okay. So I had a really hard time hearing most of that just because I'm far away from you. I heard something about false positives and something about, so I don't know if we can get him a mic, but while we get a mic to clarify, I'll just point out one thing. False positives are a big concern in the environment or in these test landscapes. So if you haven't had a chance to go down to the demo booth, talk to one of the guys at the Cortex XDR booth about the advancements we've done this year in traps or in XDR, behavioral threat protection, which allows us to kind of stay on top of all of the ever-changing threat landscape environment and deploy out new, what we call behavioral rules for detection in a silent mode. Okay, so anytime our threat researchers find any information out about an application that might be, or a behavioral pattern that might be concerning, we can test out a new threat prevention rule in silent mode and see if it would have any false positive hits from all of our millions of endpoints under management, see if our rule would actually block anything we didn't intend to. Apologize. Maybe that wasn't exactly your question, but I only caught a few words from it. Go again.
Yeah, sorry. It's going to be easier this way, I guess.
Yep.
So our main problem with the false positives is not the fact that we get lots of alerts in the SOC. We can usually handle those. The problem is that engineers are getting blocked. Like Android emulator is one of the things that's being blocked because it's using access to memory that would usually indicate something malicious.
Sure.
And then with most of the AVs that we work with, the problem is testing out how to handle those exceptions that we need to put in place. And I was wondering if you have a good method to address that issue.
Yeah,
that concern.
Whitelisting applications like that can be challenging. I don't know if you can whitelist by signer or if there's whitelist by directories or ways to do it. I don't know if others have had similar trouble or have had solutions that work well for them. I know this is an ongoing challenge a lot of folks deal with, especially in the developer space. I specifically, even though I used to write code, didn't security test it back in those days, didn't come up with anything that worked really well. So I'm open to recommendations in that area. I don't have a good answer for you though. It's definitely challenging. I would recommend if you can, I know it's challenging to sign code that you might be developing on the fly, but that might be one way to do it, and then do a whitelist by signer. I know that takes additional resources to actually do that, and usually you don't want to sign a build until you're actually ready to publish it though. So good question. Others? Okay. Happy threat hunting. Thanks, everybody.